This lesson will focus on complex numbers and how to do operations with them, specifically how to add, subtract, and multiply them. In a future lesson, we'll talk about dividing them. So complex numbers are the combination of real numbers, which we've been using for quite a while in your education, and also imaginary numbers, which will be brand new. Imaginary numbers are based on the fact that we haven't been able to do, up to this point, square roots of negatives. So the square root of -1 is equal to the imaginary unit I. That's what this system is based on. And it goes into a repeating pattern of 4 different possibilities. So if you go I squared, that's going to be equal to -1, because if you square that, the square root's gone. And then I cubed, which is these two multiplied together, gives you the opposite of I. And then I to the 4th is I squared times I squared. -1 times -1 is equal to 1. So we have a repeating pattern in the imaginary numbers for I, it keeps repeating after every 4 iterations. So the form that we're going to put complex numbers in will be A plus BI, where A is the real part and BI is the imaginary part. So we want to make sure we do these operations, and when you do this, you treat them just like you did polynomials. Let me give you a couple examples that show you what I mean by that. This polynomial here, when we add these two together, we look for like terms. So looking for like terms, you take 2x and 7x, add those together, you get 9x. So 9x. And then you go with 5 minus 3 gives you a positive 2. So combining like terms applies also for imaginary numbers. You look at these two complex numbers when you're combining these complex numbers, the imaginary parts look like they have variables in them, but they're actually numbers, but you combine like terms. 4 plus 9 gives you 13, and then positive 3i plus negative 2i is a positive 1i. So we just treat it like the imaginary numbers, and then we simplify from there. All right, what I'd like to do next is talk about that same idea with multiplication. Multiplication here, when we have polynomials, you use the double distributive, where you can go 9x times 2x is 18x squared, and then 9x times -5 is -45x. And we do 1 times 2x is 2x, and then 1 times -5 is a -5. When we combine those together, we get an 18x squared. These are similar terms, so we combine them just like we did above, minus 43x, and then -5 for our answer there. Now, we're going to do the same thing here. We'll use the double distributive just with these numbers. So real part to real part gives me 2 times 7 is 14. 2 times -3i is -6i. And I go -5i times 7 is -35i. And then -5i times -3i is a positive 15i squared. Here's where I combine like terms. I get -41i, and I simplify this. I squared, as we had on that chart above, is equal to -1, so this becomes -1 times 15 is -15. 14 minus 15 is a -1, minus 41i, for a simplification of that. All right, now what I'd like you to do is I'd like you to go to these partner problems. I'd like you to try them either on your own or if you have a partner that you can work with. Try them, pause the video, see what you get, and then come back and check your work. Now that you've returned, let's go ahead and check how you did on this. When we take this, we're going to do our double distributive, so 4 times 2 is 8. And then I do 4 times -3i is -12i. 5i times 2 is 10i. And And then 5i times negative 3i is negative 15i squared. Now I combine, when I look at these, and I get the middle two terms are like terms, so I'm going to have 8 and then minus 2i when I combine these two. And then a minus, this is a negative 1, so that turns this into a positive 15. So 8 plus 15, I can combine those two, is 23 minus 2i for an answer. Now, let's go ahead and do the next one. That was multiplication. This is subtraction. Subtraction, we're not going to distribute through the 6 and the I, we're going to distribute through the minus through the parentheses. So 6 minus I minus 10, and then minus a 7i is minus 7i. So 6 minus 10 is negative 4. Negative I minus 7i is negative 8i. There's my simplification of that. This one, we're going to go back to just imaginary numbers. I'm going to go ahead and split out in this one the square root of negative 1 times the square root of 18. Square root of negative 1 is I. Look for perfect square in 18. That becomes the square root of 9 times the square root of 2. Square root of 9 we know, so we put that in front. 3i times the square root of 2. That square root of 2 has to stay underneath because we don't know the square root of 2. This I to the 42nd, we're going to use that pattern of 4, knowing that if we have something that 4 goes into, for instance, to the 40th power, that's going to be equal to 1, and then we're left with I squared after that. Okay. So I to the 40th is equal to 1, I squared is equal to negative 1, and so I just get negative 1 when I multiply those together. Okay. So it's I to the 40th times I squared becomes a negative 1. Anything to the I to the, anything that 4 goes into becomes a 1. All right, let's try this solving problem. See if we can solve this. Typically we could use factoring or graphing, but this graph won't cross the x-axis. So I'm going to go back to trying to isolate the x in this one. So subtract 9 from both sides. So for this one, I'll subtract 9 and I get 49x squared equals negative 9. Divide by 49, you get x squared equal to negative 9 over 49. Now I'm going to take the square root of both sides. Square root of x squared is the absolute value of x. The square root of negative 9 over 49, I'll just write that out. Square root of negative 9 over 49. I'm going to take the I out of that, make it a square root of negative 1, times the square root of 9 on top, and the square root of 49 on the bottom. And now square root of negative 1 is equal to I, square root of 9 is 3 over 7. So I get the absolute value of x is equal to 3/7 I. Now, when you have an absolute value, you get two cases. You get a positive and a negative. So when I get my final answer, I get plus or minus 3/7 I for a final answer for that. So when we simplify complex numbers, we have to remember that we follow the rules just like polynomials, just remembering that we can use our rules for the new number set, imaginary numbers, in order to simplify things like I squared to negative 1. And then we remember to combine like terms and we come up with our final